9 videos ago, this lecture opened with Google Translate. Since then, we've walked through translation, translator workflow, search, information extraction, question answering, sentiment, writing assistance, simplification, and medicine. 9 applications, 9 subfields, 1 consistent story. General purpose language models plus domain-specific data plus a lot of engineering equals a product people actually use. That's applied NLP in 2026. Today is the closer. Everything Lecture 9 said. Then the pivot into Lecture 10, the last lecture in the course. Bias, hallucination, alignment, the frontier, where the field is genuinely uncertain about what happens next. The applications we just walked through are real, and they're also just the setup for the harder conversation that starts in the next video. Video 9 closed with clinical NLP, a domain where fluent-sounding wrong output is genuinely dangerous. That's the theme that runs through the whole lecture. Every application we covered has a version of the same problem: machine translation of medical documents, sentiment analysis on a coordinated bot campaign, RAG that retrieves the wrong passage, text simplification that loses the dosage. Applied NLP is a machine that produces confident output. Whether that output is true is a separate question. Today's puzzle: if the same failure mode shows up in every application, fluent, confident, sometimes wrong, is that a bug in each application or a property of the underlying technology? Both. Neither. Some mixture. This is the question Lecture 10 is going to spend an hour on. Today we set up the frame, and we packed 10 videos into 10 minutes. Today's 3 beats. First, a lightning recap. 9 applications in 9 minutes. 1 core takeaway per video. The reference paper you should have in your head for each one. Second, the 3 patterns that showed up in almost every application. Retrieve then generate. Small local models plus cloud LLMs. Domain-specific data on top of a general model. That is applied NLP in 2026. Third, the L10 pivot. What Lecture 9 studiously did not cover, and why Lecture 10 exists. Bias, hallucination, alignment, and a step back to look at the field. Beat 1. Lightning recap. Video 1. Machine translation. 3 eras. Rule-based, statistical, neural. Bahdanau Bengio 2014 attention. Modern MT is a transformer encoder-decoder, or an LLM being prompted. Data is destiny. High-resource languages work, low-resource languages don't. Video 2. Translator workflow. CAT tools, translation memory, post-editing MT. The industry employs more people than ever because demand grew faster than machine quality. Video 3. Search. BM25 from 2009 still competitive. Dense retrieval adds semantic matching. RAG is retrieve plus generate. That's how chatbots cite. Video 4. Information extraction. Etzioni's OpenIE 2011. Mintz's Distant Supervision 2009. How every knowledge graph gets built. LLMs may replace half the classic pipeline. Video 5. Question answering. Watson's 100-module pipeline in 2011. Dr. QA's 2 neural boxes in 2017. LLM RAG today. Same problem, dramatically simpler machine. Video 6. Sentiment analysis. Peng and Lee 2008. Aspect-based sentiment. Hu and Liu 2004. Sarcasm is still the hard case. Aggregate numbers on social media are assumptions. Video 7. Writing assistance. Co-NLL 2014. Sequence tagging Jek2R versus Sec2CQ. Grammarly's 2-tier stack. And the quiet homogenization of global English. Video 8. Text simplification. Flesh Kincaid still shipped in Word. Nucella unlocked neural simplification. LLMs win everywhere except medicine, where meaning drift is dangerous. Video 9. Clinical NLP. 8WAB2. Mimic. UMLS. Day identification. Clinical NER with assertion status. And a physician still signs the chart. Beat 2. 3 patterns that showed up in almost every application. Pattern 1. Retrieve then generate. In search, it's RAG. In QA, it's RAG. In writing help, it's grab the user's document context. In clinical support, it's find the relevant prior notes. Every serious system today is a retriever plus a generator. That pattern didn't exist 5 years ago. Now it's everywhere. Pattern 2. Small local models plus cloud, LLMs. Grammarly does this, ambient scribing does this, every phone keyboard suggestion does this. Fast local model handles the high-frequency cheap decisions. Cloud LLM handles the low-frequency expensive rewrites. Two-tier stacks are the production shape of applied NLP in 2026. Pattern 3. Domain-specific data on top of a general model. Clinical BERT is BERT fine-tuned on Mimic. Legal Grammarly is Grammarly fine-tuned on contracts. Every enterprise LLM product is a foundation model plus a proprietary corpus. The moat is the data, not the model. That is the biggest structural fact of applied NLP right now. Beat 3. The Lecture 10 pivot. What Lecture 9 did not cover, deliberately. First, bias. Every application we walked through is trained on data that reflects human bias. Historic gender stereotypes in embeddings, racial disparities in clinical prediction, underrepresentation in low-resource MT. We showed you the applications working. We did not show you who they work worst for. Second, hallucination. The failure mode that shows up in every LLM-based application. Fluent, confident, wrong. RAG helps but doesn't eliminate it. Lecture 10 looks at where hallucination comes from, mechanically, why RLHF and instruction tuning made it worse in specific ways, and what the field is actually doing about it. Third, alignment. Making models do what humans want, not just what humans type. The whole conversation about safety, refusals, constitutional AI, harm reduction, that is Lecture 10 territory. And fourth, the course wrap. Lecture 10 closes the whole course. 10 lectures, 100 videos, from tokenization all the way to alignment. That means video 10 of Lecture 10 is also video 100 of the course, which is a milestone worth noting now, before the last chapter starts. 3 takeaways before the quiz. 1. Lecture 9 walked through 9 applications. MT, translator workflow, search, i.e., QA, sentiment, writing, simplification, medicine. Each had its own dataset, its own history, its own hard cases. All had shared foundations from earlier lectures. 2. 3 shared patterns showed up. Retrieve then generate. 2-tier stacks with local models plus cloud LLMs. Foundation models fine-tuned on domain-specific data. That is the shape of applied NLP in 2026. 3. Every application had a version of the same failure mode. Fluent, confident, wrong. That is the pivot into Lecture 10. Bias, hallucination, alignment, and the course wrap. 10 videos. Then we're done. Quiz 1. Which architectural pattern appeared across almost every Lecture 9 application? Search, QA, writing help, clinical support, MT? A rule-based expert systems with hand-coded rules. B. Retrieve then generate. A retriever pulls the relevant context and a generator produces the output, often as a RAG-style pipeline. C. A single monolithic LSTM trained from scratch on each task. Or D. Symbolic parsing followed by first-order logic inference. B. Retrieve then generate. RAG in search and QA/TM lookup in translation. Document context grab in writing help. Prior notes lookup in clinical support. This pattern was not the default 5 years ago and is now everywhere. Quiz 2. In the small local plus cloud LLM 2-tier pattern, why does the small local model exist at all when a cloud LLM would usually give higher quality answers? A. The cloud LLM is only used for training, not inference. B. Keystroke latency, per-user cost, and privacy constraints make full LLM inference impractical for high-frequency inline decisions, so a fast local model handles those while the cloud LLM handles slower paragraph-level rewrites. C. Local models are always more accurate. Or D. The cloud LLM cannot handle English text. B. Grammarly's local grammar model, ambient scribing's local extractor, and every phone keyboard's on-device suggester all exist because latency, cost, and privacy dominate the product-level constraints, even when the LLM would give slightly better answers offline. Quiz 3. Why does Lecture 10 exist as a separate lecture instead of being folded into the L9 application videos? L10 covers a different programming language. BL9 showed applications working. L10 examines the shared failure modes, bias, hallucination, alignment, that the application videos deliberately set aside, plus wraps up the whole course. CL10 is a bonus lecture unrelated to NLP, or DL10 is a repeat of L9 with different examples. B. Every application in L9 had a version of Fluent, Confident, Wrong, plus a version of Works Worst for the users who most need it to work. L10 addresses those directly. And V10 of L10 is also V100 of the course, the finale. Back to the puzzle. Bug per application or property of the tech. Answer: both. Every application has app-specific fixes, but the underlying pattern is a general property of large language models, which is why Lecture 10 treats it as one topic. Lecture 9 is done. 90 videos of 100 are behind us, 10 to go, and the last 10 are going to be the hardest. Next time, Lecture 10 opens the frontier, where the field is genuinely uncertain about what happens next. Bias, hallucination, alignment, and the course wrap. 10 videos to the end. Hit subscribe.